Elasticity. A manufacturer raises the price of an item. Consequence? Well, you would expect the demand to drop. But the question is, will the revenue rise or fall? Let's examine this question. We're basically asking, is the drop in demand large enough where, even with the raised price, this results in a decrease in revenue? Or is the drop in demand small enough where the raised price results in an increase in revenue? We refer to demand as elastic when it reacts strongly to a price change. In other words, a 1% increase in price could result in a 2% decrease in sales. The revenue drops. This is an example of a demand acting elastic. A demand is inelastic when it is not very sensitive to price. Now, for example, a 1% increase in price could result in a 0.5% decrease in sales. The result, the revenue increases. Here, the demand is inelastic. So, elasticity is a ratio of the percentage decrease in demand to the percentage increase in price. So it's a percent decrease in demand over a percent increase in price. We'll re-examine this ratio in our first example. So we could think of this, since it's a decrease, as negative the change of demand over the total demand times 100% divided by the change of price over the total price times 100%. The calculation to find the elasticity is to take negative the derivative of Q with respect to P and multiply by P divided by Q. Now, if the demand is inelastic, E is less than 1. If the demand is valued of 1, we refer to this as unit elasticity. And it is this point where the price is set so that it maximizes revenue. The third possibility is the demand is elastic if E is greater than 1. Now, to review, what do we basically want? We're asking ourselves, how can we raise revenue? Well, if E is less than 1, if the demand is inelastic, in other words, raising the price increases the revenue. If E is equal to 1, the demand has unit elasticity. This price already results in the largest revenue. And the third option, if E is greater than 1, here the demand is elastic, then lowering the price will increase the revenue. This rubric should be committed to memory. We're going to move forward and look at two examples. First example says the consumer demand equation for a product is given by the demand equation below. Q equals 3 times the quantity 300 minus P squared. P is the price per item, and Q is the demand in weekly sales. First, let's determine the price or the price elasticity, where we set the price at $45. So, again, the elasticity calculation is negative the derivative of Q with respect to P times P over Q. So we differentiate. When I look at the function Q, I apply the chain rule. So 3 times, we bring the 2 out front, take 300 minus P to the 1 less power to the first, and we multiply by the derivative of what is inside the parentheses. The derivative of negative p is negative 1. The minus you see out front is off of the equation. Now we can simplify. You can see where the 3's would cancel and 300 minus p's would cancel in the new and the denominator. So we can simplify this equation to get 2p divided by 300 minus p. Now that we have an equation for the elasticity, we determine the value of the function when p is 45. Substituting in 45, we end up with 6 over 17. Now to interpret it. At $45, which is the price, the demand, remember it's a percent decrease in demand over a percent increase in price, the demand is dropping, decrease, 6% per 17% increase in price. Suggestion, well, since 6 over 17 is less than 1, we would raise the price. Now, what happens if we would like to set the price so that the sale of the item maximizes revenue? Now, we would like our elasticity, whose equation we had determined a moment ago, to be set equal to 1. And since we want to set the price so that the revenue is maximized, we would like to find what p is equal to when e equals 1. We solve for p. Multiply both sides of the equation by 300 minus p. We have 3p equals 300 and p equals $100. At this price, we will have a maximum revenue. Let's look at a second example. The result of a study regarding boarding schools yielded a demand equation below. Q equals 12,000 minus 2.5p. The variable p is the price. It refers to annual tuition, and Q is the demand. In this instance, this would refer to the enrollment at the school. In one region, the average tuition was $3,000. For this price, determine the elasticity. Again, we look at the equation for elasticity, negative, the derivative of Q with respect to P, times P over Q. Well, we take the derivative of Q, and that would be just negative 2.5. We bring down the negative that is a part of the equation, and we take P and divide by Q, and Q again was 12,000 minus 2.5p. Simplifying, well, we don't have many chores to simplify. Minus the negative we could refer to as just a 1 times 2.5p, and we have an elasticity equation. Since we want to determine the elasticity for a specific price, that price is the tuition, that $3,000. So we evaluate elasticity function at p equals 3,000, and the result is 5/3. Again, 5/3 is greater than 1. What's the interpretation? Well, at that price, $3,000, the demand is dropping 5% for every 3% increase in price. What should be done? Well, suggestion, decrease the tuition to increase the revenue. And a natural next question would be, let us set the tuition in order to maximize the revenue. Now, we know the elasticity would have to be equal to 1. We take our function for elasticity in terms of price, set it equal to 1. Much as we did in the previous example, we solve for p. We have 2.5 is equal to 12,000 minus 2.5p. 5p equals 12,000. P equals $2,400. The tuition to maximize the enrollment. Thank you.